Hello there, welcome to the AS Maths Applied June 2023 paper here on question 4. Past information shows that 25% of adults in a large population have a particular allergy. Ryan believes that the proportion that has the allergy differs from 25%. He takes a random sample of 50 adults from the population. Ryan carries out a test of the null hypothesis P0, where P is equal to 0.25 using a 5% significance. Write down the alternative hypothesis for Ryan's test. Okay, so the null hypothesis is that P is equal to 0.25, and the alternate hypothesis is that where it says Ryland believes the proportion that has the allergy differs from 0.25, we therefore treat this as a two-tailed test where P is now not equal to 0.25. Find the critical region for this test. Okay, so we need to take our 5% significance level and split it into two parts, an upper bound and a lower bound. So 2.5% and 2.5%. And we need to find the point at which a certain number of values or less is less than or close to, actually the question says should be close to 2.5 as possible, and an upper bound for which that amount of values or more is close to 2.5%. So what we need to do at this point here is recognize that we're working with a binomial distribution, so we need to write that down as well. X is binomially distributed with 50 trials and 0.25 probability of success. Not from this 2.5 here, but from this 25% chance up here. Okay, so let's have a look in our calculator then. We need to go to mode 7, which is the probability distribution area of your calculator. You need to go to binomial CD, and then you want to go to list mode from there. Because what we're going to do is we're going to create a list from where we think the lower bound might be to where we think the upper bound might be. Now, if we do a quick little calculation right at the top of the screen here, if we've got 50 adults, and it's probably about 0.25 probability they have this allergy, then that's going to be, with 12.5 adults that we think might have the allergy. So if we'll have to go a little bit lower than that and a little bit higher than that when we create our list. So my list has gone from 6 up to 19. I then press enter on that, and then I'll enter my binomial distribution values. So 50 is the n value, P is the probability of having an allergy, so that's 0.25. And my list tells me that when I'm down at 6, probability that X is less than or equal to 6, I get a probability of 0.0195. And the other value that's above 0.025 is about 4. So 0.0193 is definitely the closest to 2.5%. So what that tells me then is that the probability of 6 or fewer people having the allergy is less than 2.5%. That's the lower bound. Now let's go to the upper bound, and we want to find the first time that it gets close to 2.5%. And in this question here we have 18 people or fewer is 0.9712. That's pretty close to 2.5%. And the probability of 19 or fewer is 0.986. So I would say out of those two values, the probability where X is less than or equal to 18 is 0.9712. That's as close to 0.975, which would be the upper bound of the probability, where we have a probability of 0.025 at the top. Okay, so these are our two values that we need from the calculator, but what now is the answer to the question, what is the critical region for this test? The critical region for the test is the region of X values for which we would say that the null hypothesis is incorrect, and therefore we should take on the alternate hypothesis. So from this probability here, we're going to say that the critical region is X is less than or equal to 6, And from this region here, if 18 or fewer gives us this 0.9712 probability, then it's the region where x is greater than or equal to 19 that gives us this 0.0288 probability. So here we are. Here's our critical region. It's this value here, and we put and this value here. Okay, so there we are. That's the answer to part B. Let's now move on to part C. States the actual probability of incorrectly rejecting for this test. Okay, so incorrectly rejecting, let's just remind ourselves of the probabilities we had before. The probability of x is less than or equal to 6 is 0.0193, and the probability of x is less than or equal to 18 is 0.9712. Okay, so this is the probability that 6 or fewer people have the the allergy, and this is the probability that 18 or fewer people have the allergy. And if a person was in this region, i.e. less than or equal to 6, or maybe put an or there, actually I think it's an or, greater than or equal to 19, then the probability of this is 0.0193, add the very small probability, so we need to do 1 minus this, 0.9712, and if they're in this region, then we are going to reject H0. So the probability of incorrectly rejecting H0 would be this probability here as well. So I'll need to find out that calculation on my calculator. So I've labelled these as A and B on my calculator to save a bit of time, and I get the probability of 0.048. That would be the probability of incorrectly rejecting H0, because that's the probability that it would be in this region. In the last part here, Ryland finds that 10 adults in his sample have the allergy. States a conclusion for Ryland's hypothesis. Well, 10 is not in this region. 6 and below, or 19 and above, would be in the region that we reject H0. So in this case, we cannot reject H0. Cannot reject H0. This suggests that Ryland's hypothesis is incorrect. Hypothesis is incorrect. Okay, so there we are. That's the answer to question 4 with a total of 7 marks. Let's now move on to question 5.